Hi, everybody. I'm Bob Bowman, Editor-in-Chief of Supply Chain Brain, and I want to welcome you to this special presentation. AI-powered dynamic slotting drives continuous warehouse optimization, presented by Lucas Systems. One quick reminder, there will be an audience question and answer session at the end of this presentation. Audience members are encouraged to submit their questions at any time during the presentation by clicking on that Q&A icon at the bottom of your screen. Now, slotting has a big impact on warehouse key performance indicators: productivity, shipping accuracy, inventory accuracy, warehouse order cycle time, and storage density. Yet typical warehouses have less than a third of items located in optimal locations. So in this session, we're going to uncover ways to transform your slotting process, making it more dynamic by using AI to eliminate the time-consuming engineering and manual modeling required for traditional warehouse slotting systems. We'll show you a game-changing way to make slotting smart, simple, and real-time, so you get the benefits of reslotting as often as you want. With that, I want to introduce our speaker for today. Kyle Franklin is a senior solution consultant with Lucas Systems. He leads solution designs and implementations in the US, EMEA, and Asia Pacific regions, helping to transform and optimize distribution centers worldwide. Prior to Lucas, Kyle held roles in international logistics and warehousing for global logistics providers. So with that, I'm going to turn over the presentation to Kyle Franklin. Kyle, take it away.
All right, thanks, Bob. Appreciate the intro. I've been with Lucas about 7 years, but Lucas has been in the business of warehouse operations for about 26 years. We're a warehouse execution software company. We're experts in DC operations, running in over 400 warehouses spread around a little over 100 customers throughout North America, Europe, and Asia Pacific markets. People most commonly know us as the voice of Jennifer, and we've been a leader in voice-directed warehouse execution space in this time. But we've also been pioneers in bringing in AI and other advanced software techniques into the distribution center space. So what I'm going to take you guys through here is a little description about what slotting is, what machine learning is, a brief description, and then how we combine the two to provide value and optimization into the warehouse and give you some strategies going forward. So the DC landscape continues to change and become more competitive. When looking at the smiling elephant in the room, Amazon, they've invested billions in distribution operations, added scores of new facilities every year, and aggressively invested in technology. Industry best fulfillment was critical to their strategy because fast, free delivery was seen as a competitive advantage. But now that's not even related just to direct to consumer as a retailer. Amazon is taking more B2B market share as well. So nearly everyone is competing with them. So how can you adapt? To adapt to the threat, companies have changed their thinking from thinking about distribution as a cost center to thinking about distribution as a competitive advantage. Effective, efficient DC operations help you compete in today's markets and enter new ones. So you cannot weigh every DC investment on its ability to just reduce short-term costs. They've also moved from continuous improvement focus on incremental process change to continuous optimization and operational transformation. DCs need tools that have helped them manage the week-to-week, day-to-day, and hour-to-hour changes that occur in the DC. That means dynamic optimization. From large sales systems that serve your business unchanged for the next decade, they've moved to more agile next-generation technologies built to support change. A simple example is moving from more capital-intensive fixed installations to flexible systems that leverage software and other agile techniques. What are the challenges they're trying to face into? Obviously we have the e-com spike, really accelerated by the pandemic, what was already occurring. Those increased volumes put new stress on operations. It's not just e-com as well. It's, retail and store fulfillment orders becoming smaller as sites try to better optimize their commercial square footage. The increased SKU mix because of customer preference and these smaller orders leads to excessive travel around the warehouse. whether it's walking, driving, or even just the automation itself, like robots and conveyors. We see inefficient task workflows as well for end users. So sites have tried to shoehorn these new kind of processes, customers, new order types into existing processes and software packages, which can cause some major inefficiencies. Lastly, unpredictability. It's harder and harder to plan out your day, your week, your year ahead of you because unpredictable order volume spikes and changes, and even staffing levels as well. So, we've all seen that happen now in the industry. So there are a myriad of problems and ways to address them, but today's focus is on one particular methodology, and that is slotting. So what is slotting? I'm going to try to give you a very simple definition to kind of anchor to today. Take all complaints up with Bob. Don't ask me. The act of slotting is the act of trying to determine which products should be in your locations and slots in your warehouse. It's also making sure that the slots you have enough product capacity to meet expected demand. So, right sizing the slots in the products with the demand that you have. How does it typically work? It's usually done infrequently, if at all. So a person, usually one or two or a team of engineers, tries to determine new locations and matches for products. And then there's a physical move of those products and swaps or changes throughout the warehouse. For most warehouses, this happens, once or twice a year, if ever. Some are doing it much more frequently, but generally that's the kind of status quo. Why does it take so long? Why is it done so infrequently? One, it's hard. It's a hard problem. It's time consuming to figure out where to put things. It's hard to figure out, am I looking at the right data at all? Am I bringing in the right considerations? What makes the slot good or bad? You also, typically it involves an FTE who has a normal, day job that doesn't necessarily involve slotting. So they're running the warehouse, they're managing inventory levels in general. So you're kind of diverting FTE resources. So it ends up being pretty expensive. You also, a lot of slotting packages or planning strategies revolve around shutting down picking or doing moves when, an off hour. So you have to work overtime to actually execute the moves. Lastly, even if I do the moves, I take the time to do it, I make the changes happen, my ROIs could be bad in a few months, right? So if I have a highly seasonal warehouse, it might not feel worth it to move everything every month because in 3 months it's going to be bad. So you just, let things drain out and go with what you have. So we're going to look at a new approach to this problem using AI and machine learning technologies. Right now, I imagine the most common slotting, I know the most common slotting tool used out in the world is Excel, right? Which is great, but we think there's a better way. There's a better mousetrap than just simply Excel. We want to eliminate the engineering and manual modeling required for traditional warehouse systems. We want to use AI to create a robust slotting model using the spatial characteristics of the DC and the product order profile to predict optimal placement of products. And we want to utilize machine learning to continuously adapt to the DC and evolve as conditions change. So very basic overview of AI and machine learning. I am not a data scientist by trade. So again, if you have any complaints, take them up with Bob. So artificial intelligence is simply the engineering of machines that mimic human cognitive functions. Very broad definition, somewhat intentionally there's a lot of different definitions of AI. It's gotten more muddled with the proliferation of ChatGPT and other generative AI tools. But really, we're looking at anything that mimics human cognitive function. Within that, we have machine learning, which is a technique within AI in which a computer is programmed with algorithms designed to learn from data examples. And then you have deep learning, which is a type of machine learning. It is based on an approach called artificial neural networks. As the name implies, it was inspired by how our brains are architected. So how does it work in this context? So essentially what we want to do is take the right data. So that's data from automation. So that could be conveyors, there could be robot data, and then data from devices like, RFs or voice picking units. And take all that and leverage it and bring it all together and combine it with IoT data, like what day of the week is it? What month is it? Seasonality, other external factors. We use all those together and create a machine learning model used to try to find new variables, understand what variables are predictive and not predictive, and essentially create recommendations and predictions. What our engine does is take those recommendations and predictions and get them directly to managers and engineers. So in the past, companies relied on data analysts and other IT resources to develop analytic tools for use in business. This tool, what we hope to do, brings those insights directly to the end users who will interpret and implement those recommendations. We think machine learning techniques are going to fundamentally change how companies perform certain key optimizations, empower things like dynamic slotting, workforce planning, labor planning, and performance management. So when looking at the machine learning versus the typical engineered slotting approach, or even just extending past slotting to workforce planning and other techniques, the engineered approach is great, but it can be costly and it can be manual and static. So when I think of the very simple example here is look at is say engineered labor standards. To do that, I have to bring an engineer or two or many on site, do time studies, do motion studies, and figure out how certain tasks should be fulfilled. I could also, create business rules and create an entire rules engine around labor standards to help build this model, which is great. The problem is it's detailed and it's static. If things change, you're looking at reactive and historical data, and it's hard to keep up with the ever-changing DC. The rules engines can be brittle because as you add more rules, you start to contradict each other. And again, you can't react to simple changes, right? So if I say I got a whole new fleet of pallet jacks and they go 10% faster, well, theoretically, my labor standards should change. But am I going to pay for an engineer to come out and do another time study? Probably not. Maybe I should. And things start to kind of fall down. Conversely, the machine learning approach is all built with the idea of adaptability and reinforcement learning built into it. Some of these things are things you simply cannot do without machine learning. Besides trivial problems, specific coding instructions can become impossible and contradictory, and you really need to build in feedback loops into your models to be able to sustain over changes. So, our new approach based on AI and machine learning to this problem of placing the best products in the warehouse. So, when looking at a traditional approach, what do? You first build a scaled model of the warehouse to try to estimate travel cost. So that might be as simply as Excel, like an Excel map of the warehouse. But if you look at more robust packages, you might be making full 3D models of the entire DC. You need to have solid queue of each and every product in each and every slot in order for it to work fully. And you need to build and constantly tune optimization models and weighings in the system in order to calculate savings or potential recommendations. Then you need to periodically continue to reslot products. Many of the different engines require you to slot things dependently. So you have to do everything all at once or some chunk all at once or an entire zone all at once, which can add to the cost and the rigidity. What's the machine learning approach look like? Essentially, we want to learn the cost of current operations from existing data. We want to identify suboptimal product slotting and then give recommendations to users for new slotting options, especially focus on the heavy hitters. And then power a way and a process to do dynamic reslotting, or what I like to call opportunistic reslotting, in order to continually bite off what you can chew to make moves and get ROI. We have a few different objectives here with the system that we're trying to attack. One, the first one, that dollar sign, right? We want to reduce picking and replenishment costs in the warehouse. We want to reduce inventory damage. We want to improve space utilization, better cube out the facilities we do have. We want to improve worker ergonomics and safety. We'll talk a little bit about golden zone slotting and other ways to mitigate that, as well as improve picking accuracy. There are a lot of different factors that could be taken into account when you think about slotting. Here's a brief look at a lot of different ones, from the handling unit appearance to the style of picking you use there, compatibility, seasonality, all that. You have a lot of different objectives as well. Because of this, you have thousands of SKUs in locations as well. This makes for what is called a combinatorial optimization problem and a multi-objective optimization problem, which in ordinary terms means it's a very difficult problem to solve with a very large set of possible solutions. Also, once you do solve it, SKU profiles and other inputs change so rapidly that you might have something that doesn't work when your order mix changes significantly. So these, taking all these into account, these are perfect solutions and perfect problems to ask of machine learning and AI. So what variables do we take into account? What are our key ones that we're focusing on? We have a machine learning model, so we can take a lot of things into account, but we like to talk about these 6 variables. So first and foremost, most commonly, is velocity. So how fast are products being picked? How often are they being picked? And then what quantities? One we also look at is affinity. And we'll talk a little bit more about that, but that is one that has come up much more in our production usage of this solution. And that one that, simply can't be captured by things like Excel. We also look at seasonality, which are really, really important in some warehouses, and some customers of mine come right to mind, and not so much in others, but there still is some impact. Along with seasonality, you might even look at day-to-day seasonality, right? So things within a week. My Mondays are busier because we're closed on the weekends, for instance. That takes things into account. A lot of our customers specifically and a lot of operations are leveraging ways to do order batching. So we want to take that into account and consider that and kind of make a robust affinity model. We would look at SKU compatibility with slots. The simple example of this is, if I have a product that's supposed to be in a freezer, well, kind of has to go in a freezer. It's incompatible with the ambient chamber. And then we look at dimensions. So the product and slot dimensions as well. We can do this as detailed or as simple as the DC allows and the data is there. But these are the main 6 factors we're looking at. Since machine learning is designed to continuously ingest data, this solution is built to automatically handle change. With an occasional one slot or total reslot approach, unfortunately, the optimized state sort of deteriorates quicker than you think due to those changing conditions. Traditional software solutions for slotting put users through a lot of configuration pain and guesswork. So we really want to simplify that and make the end user UI tool that is easy for anyone to consume. We want to take advantage of, if we can, forecasting, right? So we want to be able to ingest forecasts. That could be long-term forecasts. I think of a sporting goods apparel retailer. They know what they made for the year. They have merchandisers who spend an entire part of the company who work on that. We want to be able to ingest that. We also want to be able to ingest something simple as they put this product on sale next week in the penny saver. So we want to be able to take those things and make proactive changes. And then we want to be able to improve productivity, efficiency, and safety with horizontal and vertical sliding optimization. So again, thinking more about that golden zone, thinking about travel distance, both walking, driving, and then vertical up and down if I'm picking things on a cherry picker, and take those into account as well. All in all, this ends up spitting out an ROI and an explanation in our UI, which we'll show a little bit later, but we think that helps motivate action in the DC. What are some of the benefits of these aims, these variables, these optimizations? So improve space utilization, right? So getting products in appropriately sized slots will allow you to store more inventory, allows you to store more SKUs in a better, more efficient way, and hopefully, require less racking or less, additional warehouses needed. Reduce the replan and picking costs. So, that's usually the headline for slotting. So you want to reduce the travel distance you spend to pick orders. You want to reduce the amount of replenishments I have to do by getting things into the right slots with the right size, and then enhance safety and ergonomics. You want to move frequently picked products, to the golden zone. So areas between the knees and shoulders are where your most often picked products are. You want to move heavy items away from top shelves because you don't want to reach above and grab heavy items that causes injuries, but you also don't want to be bending down all day at the lowest items in the ground. So you want to take that into account as well. Now, how do we set it up? So what do we need to do this? That's usually the first question people ask. So first thing, we start with a warehouse map. We can take a very simple map and build our digital map of the warehouse. You don't need to have a full AutoCAD with every pillar and post labeled. You don't need to have a 3D model. I've literally built these warehouse maps with it mounts to the back of a napkin. As long as I know where all the aisles and bays and levels are, we can start from there, and then we can build up and build compatibility from there. We also connect to a data source. So most commonly, that'll be a WMS. Could be an ERP. We also want to connect to Jennifer if it's in use at the site. It is standalone. You don't have to use Jennifer picking to take advantage of slotting, but you will get more robust data from the picking and replan activity. And we also create a method just to do simple file uploads. So that might be, again, for like product forecasts that aren't as ongoing or routine, or for some reason you can't set up a WMS integration and we don't want to go through that cost and burden. We could do a simple file upload. We want to be able to collect this data on a recurring basis. So we want that slot and product info and want to know where everything is at the moment. We want to get that replan picking activity because that feeds into our cost algorithms. And so we know if you travel from here to here and it took this long, then we want to take that into account in our machine learning model. And then we want, compatibility matrix. We need to keep that updated. So that is, what new SKUs come in, what locations can they fit in, what locations can't they, things like that. Essentially, we take those things, we throw it to the cloud. We feed it into our cloud-based AI engine, which provides the swaps for the actual move, so the recommendations. Users can request as many swaps as they want, as often as they want. So it's an on-demand type model. They can then decide to commit or reject those swaps. When you commit them, we can send them to the WMS directly. So we can send and essentially create an integration to create, what amounts to like a bin-to-bin move to swap those locations. We can also, if we want to set up an integration to update, masters or other data to change picking locations, that's possible as well. But a lot of WMSs don't like other systems touching master data. So in those instances, we can export to a file and develop things a different way. We can export to Jennifer to make actual physical moves, or print them out on paper if you have to, if that's the only way that you can feasibly do it. So, the idea here is, again, power and simplicity combined, right? We want to make this a super easy UI to use and leverage. And we want to differentiate from some of the more complex packages that require an industrial engineer to be able to run. I want my end supervisors in the warehouse to be able to use this product, or really anyone. So requesting recommendations is pretty simple. You simply have to hit the request button and the system asks you for a number of recommendations. The idea here is it's towards the end of a shift. My replan guys are all wrapped up. They have about an hour left, and I was going to send them to go clean, maybe do some training, things like that. So I have time for say 10 moves. Instead of doing that cleaning, maybe they can do those 10 moves. I can decide to make them independent or dependent. So we'll see that in some slotting packages, if you guys have seen that before, where I can say, I know I'm going to do all 10 of these moves and execute them. So I can make these moves dependent, which will take advantage of, say, more affinity style reasons. So I can maybe two products that have been getting picked a lot together. I want to move those both to the front and swap them out with two other products. So I would make those dependent changes. Or I can say, I don't know how long, my gal on the replan trunk is going to take to do each of these. So I'm going to say they're independent. They don't make them dependent on each other. And click request, and those will spit those out. Then the system will work for a second and then spit out some replan recommendations from the cloud. So this is a full web-based UI. So it is, you don't have to install software on a local machine, or you can run it on a tablet. You see people on equipment running tablets directly. They could run it right from their machine theoretically. So you can see the slot and SKUs here, and just very simply say from slot 1, this product, the air filter for Kawasaki, to move over to slot 2. The reason code for that, in plain English, this will cause or result in a replenishment cost reduction. So this likely means that this product that's getting moved to the front is being picked much more often, and it needs to go in a bigger slot because we're replenishing it too often. We calculate a reslot cost, which will, the travel time and time it takes to execute the move. And eventually the end goal is to spit out an ROI. So if I execute this move, I will make my money back in 4 days. So it feels like a no-brainer to do. You can have other reslot reasons, like a product affinity that, like I mentioned earlier, that's one that is coming up much more often than we initially expected, and is one that's really hard to kind of calculate with Excel or any kind of simple product velocity based module. But a number of other reslot recommendations there as well. In addition to that, we generate heat maps. We can look at a few different metrics and color palettes. So here I'm looking at picks on a uniform distribution, and I can see my blades area here is really hot, but I expect that. That's what we sell the most of, and those are my optimum slots, so that's fine. I see some red way back here in the top of the warehouse. I might want to think about moving those products to a more optimum slot if possible. I can change color palettes. So if somebody is red, green, colorblind, we have a few different palettes built in, or just wants to stylize it differently. And I can look at different metrics as well. So here I'm looking at replan visits. I can look at different distributions. So if I want to see rapid changes, I can look at the logarithmic distribution and other configurations there. All right. Last slide for me before we get to the panel. So other features I wanted to highlight. We do allow you to do what-if recommendations. So if I know a product's coming in, I upload a forecast and I want to see if it makes sense to move it to the front or move it to an optimal slot. I can ask the system, is there a better slot for this product? What would happen if I did this swap? Another thing very important as we talk about that continuous optimization is providing user feedback to the model. So if I reject a recommendation, for instance, I can give a reason for that recommendation, and the AI engine will incorporate that feedback. Most simple example is I get a product, a new SKU in, the product master says it's one size. When the user goes to try to do the swap, it doesn't work. So we reject that recommendation, and now the AI engine incorporates that and says, hey, maybe this product size is wrong. I won't recommend that type of slot again. We can also implement custom columns and show things like current stock levels. So you might want to wait till a slot goes down to 0 before you make a move, makes the move cheaper. Whether there's any orders allocated against a slot, things like that, whatever you can dream of that makes sense, we can implement that as a custom column for your client version. And with that, I think it's time to move to the panel. I've been talking a lot, so I'll let you guys ask questions and see if Bob has anything for us.
Thanks very much, Kyle. I'm here to take on all those complaints that you would not accept on your own shoulders. That's fine. Yeah. That's what I'm here for. That's the moderator's job. Let's do a little panel here before we get into the audience questions. But while I am questioning Kyle with a few questions of my own, audience members are encouraged to keep on submitting your questions by clicking on that Q&A icon at the bottom of your screen, and we'll get to as many of your questions in the audience Q&A portion of this presentation as possible, as much as possible, time permitting. The basic question here, Kyle, is how does a user get the most out of this software? We hear of a lot of warehouses buying slotting packages. They never get around to utilizing them. They're kind of obsessed with the shiny thing of the moment. How do you make sure that doesn't happen here?
Yeah. So I'll kind of answer that in reverse order. So we've definitely seeked to design a solution that anyone can use. I highlighted some of the usability aspects a couple times. We don't want this to have to sit in the industrial engineer's office, right? That's how I think a lot of these develop Dust is only a certain subset of people are trained on it. It's a training and consulting time is required to really understand and build out the model. So we taking some of that friction out in our design. At least I like to think. How someone gets the most out of it by using it, right? So request recommendations, try to be opportunistic and use the solution as much as possible. That's how you're going to get the most ROI out of it. Waiting 3 months to turn it on and use it or make a couple swaps is not what it's necessarily designed for. It's going to be better the more often I use it and the more I continuously optimize my warehouse. So as things change, new products come in, seasons change, the best bang for the buck I can do is to run the heck out of it.
Kyle, there have been many tried and true techniques over the years of addressing the whole problem of slotting. We've had first in, first out. We've had last in, first out. We've had ABC designations indicating inventory turnover rates, things like that. All of that, I guess, has worked as far as it goes. But again, as you point out, a lot of it is manual in execution. So how is this solution better than doing it with Excel or other manual means, even based on those techniques that, for their own purposes, have worked up to now? What do the algorithms take into account that these other things don't?
Yeah, I think a lot of it. So I mentioned one that our data scientists have hit on a few times is affinity. So it's really hard to figure out affinity and take advantage of it in something like Excel or a more simple tool, right? I can say velocity and get everything into an A mover slot, but within my A movers, one, I could make too many of them, right? And now I have things spread out. I could cause congestion by funneling things to too close or small of an area. There's a lot of there's so many variables. Like I showed that little word cloud of all the different factors that come into it. It's a multivariate problem. So doing something with a simple, like, okay, get my highest movers to my highest slot is just a little more limited than I think we can go and continue to improve here. So affinity is definitely the big one. Replenishment costs. One of my other solution consultants, a principal engineer here, Ron, always talks about the idea of flow, right? I don't want to look at product velocity necessarily, but cubic flow. The real world example is that during COVID, there was no toilet paper on the shelves, right? That's not because suddenly every single person bought way more toilet paper. It's just harder to restock because it's bigger. And so if two more people buy toilet paper, it clears out the shelves, and then he causes panic. So making sure you have enough cubic volume to match the velocity as well and getting that right sizing right. All of these things are really hard to do with simple packages. And then to continually optimize on it, you really need machine learning and other techniques to help you out.
Mm-hmm. Well, there are, however, various types of storage strategies that must be put into place in various warehouses with their own unique needs. There may be product zones. There may be the need for temperature-controlled storage. There may be security considerations for highly regulated product. How do you account for all those in your model?
Yeah. So one of the main outputs of a sliding project when we're setting this up for a customer is the compatibility matrix. And that's what we work with the customer on and trying to figure out and suss out those things. So essentially, we can have an ever changing or categorized compatibility matrix to take into account those various things. So when we don't want to rely on simple slot size to be a determinant whether a product should go into this slot. So we can make that matrix as complex or as simple as we need. We might say, very simple customer, they got no freezer, all the products are the same size. Very basic example, that compatibility matrix is going to be real straightforward. It's going to only take a very little amount of time to work out. But the more complex that model gets into, and then you start to realize, man, I couldn't really do this without a real model helping me out, figure this out. Or if I were using a more complex solution and I add a new section of the warehouse, how am I going to set this up? Do I need to pay a consultant to come and like figure out how to add this into my software package? Well, no, now we can just add it to the compatibility matrix, or you guys can update it on your side depending on how we set that up, and we're good to go.
One of the most compelling features that you described in your presentation, Kyle, is the flexibility and the agility of this system, its ability to handle change. And you mentioned the idea of modeling, and especially what if scenarios. Could you talk a little bit more about that as a digital exercise? I know these days when we think of what if, we hear a lot about digital twins and things like that. Is that a feature here, and how does that work exactly?
Yeah, so the what if is great. I think it's good for a few reasons. One, I mentioned the like forecast aspect of it. So if I know a product has been like flying off the shelf, someday, one day, but maybe I don't have forecasting built in, I can see how that is going to affect my. I can quickly see how that's going to affect my productivity. I can do the what if to say, should I move this to the front? Which product should I move out? Does this need a better slot? And I can have a user directed function. Another thing is simply like people like we know if we're getting used to machine learning and AI tools, I think people are still trying to get their arms around it. So an ability for a user to say, hey, does this make sense, to almost validate the tool? Like, hey, I know this should be in the front. And if the system agrees, it almost helps you validate that kind of stuff as well. So, I definitely see people using it more, first up as they get used to this system and develop trust with it, for sure. But it just allows users some control. So it's not just a black box that they send off things to.
Okay, thank you. At this point, let's get into the audience question and answer portion of this presentation. Audience members are now invited to continue to submit your questions. We have a good number of them now. Very good audience participation, Kyle. It definitely speaks to the compelling nature of your presentation. Let me start with this one. Maybe just asking you to elaborate a little bit on what you already have talked about, and that is the ideal type of data that you need to recommend optimal inventory placements. Talk more about that.
Yeah. So going back a step or two, Lucas, we've been around a long time. We have integrated to a lot of different systems. If you look at our list, there's a lot of SAPs, there's a lot of Manhattans and things like that, but there is a lot of old ERP. There's a lot of AS400. There's a lot of essentially, I think, access, right? We've integrated everything. We've gotten good over the years at figuring out how to make do with substandard data, and figuring out how to massage it and get it used into a way that we can do it. So I say that to say there's not any crazy high requirements. The more data you give, the better. We definitely need some kind of compatibility matrix or some set of like figuring out which slots can't go where, so we don't give bad recommendations to the users. The more accurate cube data, the better. We'll be able to provide more accurate recommendations, but we can work if it's not 100% correct because very few warehouses are, right? So I mentioned, tying in Jennifer pick data. That definitely helps, but it's not necessarily required. Slotting is standalone. But if we do have pick data, we can separate things from, this pick took this pick took 4 minutes to execute, so I can approximate travel to, if we know Jennifer's plugged in, we knew how long it took the user to get to that location and then execute that pick. So we can start to tease out and separate those things. So the more data is better. Forecast for sure, but we know a lot of sites don't have that. So we essentially create pipelines in a way that people can give us what they can give us, and then we can let the machine learning engine take it from there.
Thank you. This questioner wants to know any other applications, or what other applications do you see this model being useful for? Specifically, can it power directed put away?
Yeah. So right now, the first use cases we worked on were more of a fixed bin style, but definitely should be able to power directed put away. So if you're doing a completely random dynamic storage strategy, to have a user say, scan a location and have the cloud give back a recommendation, we definitely see as a use case to power more advanced directed put away. So, that's again taking more advantage of live velocity data, skew and affinity data. We think there's a great market out there to help with that, because as every other warehouse I walk into now, there's so many SKUs that they can't stick to fixed bins. It's so hard. Or they maybe have a fast bin area where they stick to like their top 100 and everything else has to be random. So we want to take advantage of that. And we're always trying to recommend ways to help take advantage of that.
Like it or not, we're still in the age of SKU proliferation as well. So
Yeah.
so much more complex than it used to be in the old days. Not saying I remember that, but still, that's what I hear.
People love choice, Bob. People love choice.
That's right. Audience member wants to know how long this whole thing takes to get stood up. Do I need to bring in engineers to do a survey or 3D model the warehouse?
No, definitely not. Like I said, I've made maps from lots of junk over the years. We've luckily improved our map tooling, so it's not going to pull as many hairs out or cause as many grays. But we don't need a full huge study. We don't need AutoCAD or anything like that. We can build a simple warehouse map. We don't need industrial engineers to come out. I mean, we have a couple here, but we don't need them necessarily to come out and do a full crazy survey. I would say a typical process should be about 3 months, start to finish. Most of that is figuring out the integrations, if any, that we're doing to the WMS. So get those APIs and things hammered out, figure out how we're going to get data into the system on an ongoing basis. We go into one part of the product is essentially a pipeline that helps massage the data and get it to the right format. So we work on that. And then, the bulk of the work then on the customer is helping us figure out that compatibility matrix and how we want to set that up going forward. So that's, but like the software itself is essentially built. We're really just building the pipelines.
Here's a question that's very timely given the proliferation of systems in warehouses and all they work together or don't work together. This questioner is saying, how does your tool integrate back into my WMS, my warehouse management system, after making recommendations?
Yep. So that is a little bit of a choose your own adventure. So, we're used to integrating, sending pick confirmations and replan tasks and things back to WMS. For fixed bin locations, we recognize that this is a little more sensitive for certain WMSs. So we don't have a standard like, hey, this is how it's going to happen every time. You have to take it or not. We're going to be flexible about how we send data back to the WMS. So we love to execute these tasks with Jennifer and be able to send it right to a picker moving things, but we don't necessarily have to do it that way. We can send a simple file upload back, or we can, we've seen some people say that they're going to kind of stick to more of an offline approach, make the moves in their system and their master system separately so that they don't have to touch an older system that they don't want to change. So there's a few different options there.
Here's one of those questions. What about my operation? Sounds great, but what about me? This person says we have very complex warehouse configurations. Would that cause any specific challenges to the optimization process?
Not necessarily. I would say, again, kind of going back to that compatibility matrix, if we can rationalize the rules and what needs to be there, then we can figure it out. If anything, it lends you into needing a tool like this more than the other way around, right? We don't want two guys to leave the organization and no one knows how to slot the warehouse anymore, right? That's a fear you have, right? When it's all tribal knowledge and it's stuck in a few smart people's brains, which is great. They've been able to get to where they got now. But if they're out sick or they leave the organization, you don't want to be stuck with all these complex rules with no tool to help alleviate that. So as long as you can rationalize it and we'll help you explain it to us, we're used to that as well, then we should be able to figure it out.
Questioner wants to know, how much historical data are you using to assess product placement?
Yep. Rob has told me at least 1 year is great, ideally 2. That's the rule of thumb that we want to take for like order data. And then if you have more raw detail picking data, we'll take it from there. But to get a good idea of velocity, like a year is a good amount. We can do it with less, but a year is good because we want to capture full cycle seasonality, even in a somewhat non-seasonal business.
Thanks. What kind of data warehouse or database requirements are needed to support these large data sets and algorithms?
So this solution it differs from some of our other solutions as we're hosting it on Azure and our cloud. So as long as we can set up an integration to get or figure out a way to get data out, we will host that and take that infrastructure burden on ourselves so that we can so yeah, so we don't have to burden a customer with all that infrastructure and have to have them set up Azure and everything like that. So we kind of have a multi-tenant cloud set up here for that.
Mm-hmm. This one again is kind of asking you to talk a little bit more about the integration aspect. How do I implement your software to a custom in-house built ERP, Enterprise Resource Planning System, or for that matter, a WMS?
Yeah. So we've done it. Say we have 100 customers, we've probably done it 40, 50 times. So a lot of older, or not necessarily old, but a lot of custom one-off built, ERPs, AS400s. So really, if we can get down to the simplicity of like, can you give me a slot? And we know where all the slots are. Can you give me the product code? Can you give me some idea dimensions? And then, when it was picked and what order or whatever it was picked in, we can take it from there. So we can do a full integration, do a full web-based, interface API. We can do flat files, which we've done for years and years. Set up an API, whether FTP or anything like that, or we can literally take a simple Excel if we have to, and we can figure it out that way as well. So we've got a lot of options.
You addressed this briefly in your presentation, but let me pose the question anyway, Kyle. Does the system consider pallet weight so that the heaviest pallets are stored lowest, lightest up high for rack safety?
Yes. So that's definitely taken into account. So typically we think about golden zone from like a person walking around in a rack, but we also could take that into account in the optimization there. We can decide to be strict about it and say compatibility, like, hey, these pallets of dog food can't go above the first level at all. Or, excuse me, we can be more complex, less simplified about it and say, okay, well, we want them lower and we can nudge them lower rather than drag them above. So yeah, that's definitely taken into account.
Thanks. How does the system handle new items that don't have historical information yet? And a lot of new product stuff out there these days. How is AI going to help in this situation?
So if we have, so one thing which would help is if we have product categories, we can take that into account in machine learning algorithm. I know that we've kicked around the idea of, even like recognizing product names and like product families, like manufacturers, that can help kind of make a guess at what it should be as it comes in. And then, we can like, this is one of the benefits of machine learning. It can kind of guess at things. And then if it gets it wrong, which it might, right? When you go to reslot it, you can reject those recommendations and update the model that way. But we can look at holistically, like other data factors in order to make guesses for new products.
Again, with the integration question, this is so vital these days because there are so many systems out there.
Yeah.
How do you integrate an ASRS, an automated storage and retrieving system?
Good question. So like, I don't know if I've thought about how to use this tool for someone's existing ASRS, because their slotting model is very different from what you would do in like any kind of manual picking environment, right? And I don't know if they would like us touching it very much, but I could be wrong. I might have to take that one and think about it some more. Just like the speed, like if I think of like an auto store, for instance, right? The speed and factors are a lot different, and there's more cost to going vertical, for instance. So I don't know if that model would be the exact same, but I don't know. I have to think some more about it, to be honest with you.
Yeah, good question though.
Yeah.
How does this AI technology compare to the current voice pick module logic Lucas has in the field today? Is it more robust or dynamic, the same, or more limited than the current technology?
So it's a good question. So I would say to answer it very simply, it's a little bit different. So one big difference is, a lot of the optimization here is running in the cloud, because we can give it a little more time to do. It's not like just in time. Like when I'm picking and I say get work and I want to start something, I don't want to send something off for a long time, right? I want to be able to get things rapid. So we typically do things closer to on-premise, or it's a single tenant cloud instance in a couple instances. We do use a similar way of mapping the warehouse, and that travel cost approximation is very similar. So actually, we started with dynamic work optimization, which is our pick path and batching algorithms, and we actually flipped it on its head to do the slotting. So I actually started with that. And so though that the methodologies are very similar, like how do we figure out to reduce total travel in the warehouse, and use digital mapping tools that we can actually calculate and run algorithms against versus something sitting and smoking in the corner because it's so complex of a problem. We figured out how to get that down and get that fast. So it's a little bit different, some of the same problems, but a little different. I wouldn't say one's further ahead than the other. It's just different problems to solve.
Questioner says, you mentioned that we can consider allocating the goods somewhere else where the goods are not so concentrated in one spot. That was marked red in the warehouse map. Mm-hmm. Why is it better to allocate the goods in different warehouse shelves?
Yeah, because congestion. Congestion. If you've overdone, if a lot of people have sliding horror stories, it's like, man, I crushed this slotting model. I did in Excel. I got all the fast movers in one spot, and then you had all the pickers running into each other, right? So you do need to somewhat spread the love with both this engine and the our dynamic work optimization. Take into account is like that raw travel distance and using Jennifer's pick data to see what people actually did versus what the model was. And what that can do is instead of saying, okay, these A's are my fast movers, we actually look at what people did. And so you can spread out and say, well, this one is in the next aisle over, but it's at an end cap. So it's an ideal position. And spread out those, quote unquote, A mover slots into not just, fixed bins, but you're looking along travel paths, if that makes sense.
Mm-hmm. Questioner says, could you elaborate on what approach the tools can take to full case, pick to pallet, warehouse work, and slotting decisions with regard to stackability, crushability, food safety requirements, like raw meat, organic, blah, 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 and packaging characteristics like open top case. That's a lot of parentheticals, but yeah. Can you address that?
Fantastic question. So mainly that is addressed in the compatibility matrix. So definitely the food safety stuff, like having inorganics and organics in different places. We can very strictly limit certain types of products from commingling there. The getting things in the right weighting system is a little bit of a mix of the compatibility and a little bit of the mix of the data that we feed into the system. So we might take weight, for instance, as a full pallet of what the weight is, and take that into account to make sure it's slotted a little bit earlier in the most expected pick path and handle it in the model that way. It's definitely something that is complex for sure, but the compatibility matrix is probably the simple answer. And you guys help us figure out what your requirements are, and we will make sure that the engine respects that essentially.
Okay, thanks. Quick answer on this one, I hope. How adjustable is your model toward balancing the different objective functions of cost, affinity, line volume, or whatever else is used?
That's a great question. So there are configurations the user can use to change what my replan costs are, what my replan labor rates are. We can rescale and adjust the map as well to kind of adjust that. There's some settings in the engine in general, but we don't try to over tweak the engine because we want it to, we want the machine learning to take over. We try not to be smarter than the engine. So a lot of that is built in there, but willing to also take feature requests on how else we would want to add switches into the engine to change how we consider some of that stuff.
Well, Kyle, the only complaint that I have is that we're just about out of time, and I'm very sorry to have to say that because this has been an incredibly interesting and edifying discussion on this topic. But we do have time for just one final question, and here it comes. How is move ROI calculated? What's considered there, and what should users be doing to justify the investment and be best prepared for that exercise and requirement?
Yep. So, so for move ROI specifically, what that is looking at is the travel time it takes me to replenish that move, my replan driver, forklift, whatever costs, and then it's looking at how often I'm picking that, and then my pick time, travel time, and looking at how much more money I could save if this was in another spot based on a forecasted machine learned derived answer. So that's generally how it's calculated. And like I said, it's looking at velocity, it's looking at affinity to try to get down to a actionable number that users can use. And that's what we think is very important in the design of this is hey, you should move it here. It's great. You should move it here because you're going to get paid back in 3 days. It's even better. It gives people incentive to action. What that does then in turn is gets users incented to action to use the product, right? Your ROI for this solution is very dependent on how often you use it. We want people to use, do this as much as they can. I call it opportunistic slotting. If I have a little bit of time before the end of the shift and I have some free time, I want to be able to request and take advantage of these moves. So I really need to focus on using as much as possible. So that'll help the move ROI helps that. And that's how I think people get best use for sure.
Given the incredibly growing complexity of warehouses and the numbers of SKUs and products and the number of processes that are required and the demands of customers, it sounds like this kind of a tool, Kyle, is absolutely essential in today's modern day warehouse. Kyle, I want to thank you so much for that great presentation and for that really excellent audience participation too. It was great. Your questions were also very excellent. So thanks very much for that. I do want to bring our audience's attention to this particular guide to learn more about Lucas Dynamic Slotting. Distribution Transformed, it's called. There is your URL. That, of course, will be provided to all attendees after this presentation as well. So if you don't have time to copy that down, don't worry. It'll be sent to you. Kyle Franklin, again, thank you very much for that presentation. Audience, thank you again also. And everybody, have a great day.